doing the problems. And problem number 1. Problem number 1, and we have a hinge structure. Now let us move a little bit closer to the screen. Now I hope you can see more or less okay what is going on here. And we have hinge structure, something like that. And then we need to find speed and acceleration of point Q here, over here. And this is 2 times as long as that. And we also have here, we have angle OPA is alpha. So this angle here is alpha. And so, of course, this is also alpha. And now, as for a speed of point Q, then because this point here is moving with speed v, and here this point is going to move with speed v. So this point here goes down with the same speed, downward speed is the same as for this point here. So we can calculate vertical speed component. But let us see, we can also try doing that way. That we go to the frame of this point here, for instance, and then calculate the speed of this frame here downwards. So if this goes with speed, instantaneous speed here is perpendicular to the axis, like that. This is instantaneous speed value here. So due to symmetry, this point here is going down, obviously, with certain speed u. And now we can...
u is 2v?
Not exactly, but u is 2 times the vertical component of v. Because v here is not vertical. If v were to be vertical, then yes, then it would be 2v. But now v has... v is now what is the angle exact now of v respective to the vertical. So if we take here a line bisector here, then we have v is perpendicular to this line here. So here is right angle. Now if we were to return, v would go to a vertical. So here is alpha over 2. So u is equal to 2 times v times cosine of alpha over 2. Do you agree?
Mister?
Yes.
Yes, go ahead, Khalid.
I think in the test it was written v is the vertical component.
Yes, that's what was written in the test. It's downwards.
Okay. So you assumed it is vertical component. All right.
Yes.
We can. So I can keep this in mind. Actually, what I had in mind was that v is a speed of the point P. So it can because it rotates around this point here. Then the speed cannot be vertical. So speed can. But if in that case, if you assume that v is the vertical component of the velocity, I can have this in mind, and I can actually do this problem using that. So please tell me, who of you did everyone of you consider v as a vertical component of velocity? If yes, then we just go away and solve it that way. All right. Then let us assume that v is not the total speed, but the vertical component of the speed. Okay, then this thing here is v. All right. And then of course here u is 2v. Indeed, in that case, and then now in this frame, we need to figure out now what is the if we consider now things in the frame of this point here. So this rotates. What is the angular speed now? Angular speed would be now
I got that it would be the square root of 8v.
Square root of?
Okay. The square root of 8v.
Okay, let us calculate and see how what it will be. Let us here. Yeah, side length is here is a. Now in this frame of this point here, so this point, what is the velocity of that point? So it has now vertical component is v. If I am now in the frame of reference of this point point A over here, in the frame of reference of point A, so this draws a circle, and the vertical component of that point is now v, but it is upwards, because we are in a frame which moves with 2v, but in this moves with v. So related speed, vertical component of speed is v, but it is upwards. So now in this frame here, this point moves with v up, and it means that it has because it rotates, it has now actually velocity itself is that way, and if we project it to the vertical direction, then we obtain v. So modulus here is because of that v divided by, now what is angle here? It was alpha over 2, right? Alpha over 2, and so v divided by cosine of alpha over 2. This is the speed of this point here in the frame of A. So that angular speed would be omega would be v divided by A and cosine of alpha over 2. Would you agree with that?
Ah, yes.
Okay. Then now we can calculate the speed of this point here, which is 2 times bigger. So it is we multiply by 2 a, omega times 2a gives us now 2v divided by cosine of alpha over 2. But this is the speed, vertical speed, and the modulus of the speed in the frame of A. Now we need to have a vertical component on horizontal component of that. So vertical component is going to now we have here again alpha over 2 here. This angle here is alpha over 2, I think. Which one is alpha over 2? This one here is alpha over 2. And so this angle here is alpha over 2, so that now horizontal component is going to be horizontal component is going to be this thing here multiplied by cosine of 2 alpha. Well, that is to be expected. Actually, you already knew that this point here, if this goes down with v, this goes down with 2v, and this goes down with 4v. So this was actually in lab frame, I mean. In lab frame, this point here goes down with speed 4v. Okay, let us say that here in this frame, the vertical speed v vertical is equal now 2a omega, equals 2 a omega cosine alpha half equals 2a. But this 2v, sorry, it equals 2v. And this is in frame which moves with speed 2v down, so that vertical velocity in lap frame is 2v plus 2v is 4v. And that 4v we already actually knew from the very beginning, because this point goes down with speed 2v, and this goes still with 4v. It's quite obvious now from similar triangles, I presume. Now, this is what about vertical component of the speed, but we need to still figure out the horizontal component of the speed.
Mr. We can find it the same way. Like for point B, P, we can find the velocity at x-axis, and they're related to velocity of x-axis at point Q. The same way we did the vertical component.
Yes, exactly. So this is this vertical component was 2a omega cosine alpha 2, and now we have the horizontal is 2a omega sinus alpha 2, 2a omega sinus alpha over 2, and now we have sinus divided by cosine, which gives us tangent. So it will be 2a omega. Now I will plug in omega from here. So a cancels away. We have 2 v and tangent of alpha over 2. And this is a horizontal component. And now, because our frame goes down, in lap frame and in this frame, horizontal component is the same. So we can now finally write v from Pythagorean theorem as square root of c squared plus that square. So it will be now 2v and square root of, here goes tangent square alpha, and here goes 2 squared, which is 4. Okay? And this is about speed. Is this okay? Hello?
Sir.
Yes?
What is the horizontal component for point P?
Horizontal component of point P, v times tangent alpha over 2, because it goes, the velocity is perpendicular to the rod, and vertical component is v. So here for angle which is formed here is alpha over 2 with vertical. So here this angle here is alpha over 2. So if this is v, this is v divided by cosine alpha half, and here is v multiplied by tangent alpha half. So horizontal is v tangent alpha half.
Yes, so the to find the Q, we can just use the ratios of the diagonals. I think it's faster than the reference rate.
What was your point again?
I said that we can use ratio of diagonals and it will be the same, right?
So yeah, we can also another way of doing it is that we find this point here moves down with speed v. So from similar triangles, we can conclude that this point here goes down with speed v, and this point goes here horizontally with speed v tangent alpha half, and so this is 2 times bigger triangle. So this is 2 times bigger. So we could have obtained probably the horizontal component of this point Q in an easier way also.
Yes.
Okay, but answer is still this. So shall we go on with acceleration? Now, as for acceleration,
Wait, Mister, what's the final answer for the velocity?
Here, this thing here. Now, everyone happy with that?
I don't feel like I'm happy with that.
You had some mistake, Zara?
I mean, I had the same, but like I had the square root of a to v. V
Square
squared.
root of Zara, don't worry too much. Even if you have some mistake, it's not. It doesn't mean that well, you still get some marks and you worked well. So don't worry, Zara. You don't need to worry. Yeah. I had already actually. I gave report to Talal and Abdulaziz, and yeah, well, you worked really hard, and I was happy to have you. So don't really worry about if you have some mistake.
Okay, thank you.
All right. So now let us go to acceleration. And now, as for acceleration, we first need to figure out what is acceleration. Well, there are different ways of how we can do it. So as a matter of fact, we can also here use coordinate-based approach and take derivatives of the coordinates. But let us do it like we did at the beginning. So at the beginning, we went to a moving frame of reference. So we can, for instance, go to a frame of reference of this point here. And then, well, we ask what is the acceleration of this point here. And because this moves along circle with constant speed now, which is important now that it is, wait. Now I guess, guys, there will be a little bit a problem when we go to, it depends how you understood the problem, because you understood that it's going, it has constant speed v down, then probably in that case, we need to solve it a little bit differently. If this moves with constant speed v down, then this point here moves with constant speed 2v down. And now this speed is constant. So actually how I meant the problem, but you understood in a different way. I meant that this point here moves with constant speed along circular trajectory. And then it would have only a radial component of acceleration, no tangential. But now, if we solve it so that it has constant vertical speed, then it will have also tangential acceleration. So I presume we are going to solve so that it has constant vertical acceleration. Is that right? Constant vertical speed. Is that right?
Yes.
So we say that this 2v here is the speed of that point A, which is 2v now, this is constant. Okay, and if so, then of course we go to the frame of reference of that point. And in that case, we have this thing here rotating with the speed of, we have still already omega here written somewhere. So omega is this thing here. So omega remains the same even if you go to rotating frame. And so this is the angular speed. And then we have here, for this point here, we have a centripetal acceleration here equal to 2a multiplied by omega square. And this is going to be now v square, 2v square divided by a and cosine square alpha, I presume. 2v square divided by a and cosine square alpha. And this is centripetal acceleration. But now the direction of the acceleration itself is strictly vertical because sorry, strictly horizontal, because I know this point, vertical component of this point is constant. So it has now only direct acceleration which directed that way. So, and this centripetal acceleration is the radial component of that acceleration. So here is the full acceleration, and this is centripetal acceleration. And here is again alpha over 2. So that here, this acceleration now here is going to be A is AC divided by cosine alpha over 2. And so this equal to 2v squared divided by a cosine cubed. This was also alpha half, I guess. I made mistake here by alpha half. A cosine cube alpha half. Something like that. Is that more or less all right? So we
yes.
We go to a frame of reference on point A. We see that this moves along circle. So we find centripetal acceleration, which is radius, which is 2a, and multiplied by omega square. But omega square, we had an expression already. And then we plug in, and then this goes to expression like that. And then from this triangle, because we know vertical component of this velocity is 0, acceleration must be horizontal. And then we divide this by cosine alpha half to obtain hypotenuse. And so altogether it will be 2v squared divided by cosine cube alpha half. Did any one of you obtain here the same result?
I solved like exactly the same way, but like a slightly different result.
Mm-hmm. Okay. Now,
I guess my mistake was finding the vertical velocity.
Okay, I see. All right. I'll keep this in mind when grading that. Usually carryover mistakes are don't. I will not subtract for carryover mistakes. So if the approach is correct and the mistake carries over from previous calculations, then I will not subtract points. All right. Now, is this problem finished?
Mister?
Yes.
I have something. So I sent you 3 emails because the first 2 wasn't complete because I don't know what happened, but like my connection did something. So the last email is the email that's
right.
my solution.
Okay. Okay. That's fine. No, but what I'm worried about, I still don't have a solution from Ali. This makes me more worried. Anyway, let us continue.
Ali's not here anyway. Like he didn't join yet.
Yeah, he's not here. Yeah, that's right. Now we'll go to problem number 2. We'll go to problem number 2, and this is about taking derivatives. This is about taking derivatives. So we have here circle here, and then we have thread goes like that, and then we pull it, and then determines the speed and acceleration of the ring B. And we have here now angle alpha. And so what we shall do now is we express this length, that length, both in terms of alpha, and then take derivative of it. And well, I guess there are different ways of also doing. First thing is that if we take here actually what is helpful, if here is alpha, here is 2 alpha. So basically what we need is a derivative of alpha, because if we know alpha dot, which is omega, then this thing here, which is 2 alpha, this goes with 2 omega. Okay? So once you have alpha dot, we have angular speed here, and then v is just r times 2 omega, and acceleration is r times angular acceleration of this thing here, epsilon. So this is a little bit that might have been a problem for you, because we did not solve problems with like I think inscribed angle and Thales this kind of thing. So this might have been a problem for you. I don't know how was it. Did you have trouble of relating angle alpha to the position of point here on the circle?
Well, Mister, I was waiting for you to ask how was this problem, because problem 2 was the hardest for me. I didn't have a problem like relating these angles to the length, but like I had a problem to find an answer, because there's a lot of variables and there's a lot of things. Like I wasted more than 8 papers on nothing.
Oh,
I felt so lost.
okay. Yeah, I understand fully that this is like a difficult, maybe yeah, because I was looking which nice problem can I take which already did not do, and then I came up with this geometry. But then this geometry, if you are not very fluent with geometrical tasks, then this thing here that basically the only thing what you need to do is draw diameter, draw here radius vector. Once you draw a radius vector, and if you know that the central angle here is 2 times bigger than the inscribed angle, then you're done. Basically, because this is radius. This is also radius. So this is isosceles triangle. So this angle here equals to that angle here. And then the sum of internal angle is 180 degrees, which means that this angle is the sum of those two. So you'll see that this is 2 alpha. And then, but I understand that if you're not very used to geometry, then that might be a problem for you. And so if you have this figure here, then this point here moves along circle around this point here. And what you need to know is angular speed of that, which is 2 times angular speed of that line here. And then, but let us finish then that problem. Then let us finish that problem, and it as follows. So now this length here now is going to be, if this is 2r, then this length here is 2r multiplied by cosine alpha. Is this, okay? Because this here is a right angle. Do you know Thales theorem? So if you have diameter and the triangle, then this is right triangle. And then this is 2r, this is right triangle, so this is 2r multiplied by cosine alpha, and this here is 2r sinus alpha. And then this is all together the length. And then we take derivative, and then we obtain 2r multiplied by derivative of cosine alpha, which is now minus sinus alpha, multiplied by alpha dot. And follows by plus 2r, and the derivative of sinus is cosine alpha, and also multiplied by alpha dot. And this is equal to speed v with which we pull here thread, because this is the total length of the thread here. So the change of the sum is as much as we pull the thread away. And now from here we can express omega, which is alpha dot, as v divided by 2 and divided by cosine alpha minus sinus alpha. And then the speed of point B is radius multiplied by omega equals to radius V divided by 2 and divided by cosine alpha minus sinus alpha. So it seems actually this problem was difficult to everyone, and I guess I should have done with you a little bit more geometry, but because I just kind of didn't figure out that you have difficulties with Thales and such kind of geometry. So in that case, just take it as that now you learned about such kind of tricks.
Mister, there's something so stupid I did. Okay, so I got all the geometry right. I know that's 90 degrees angle, but like I didn't do the 2r cosine alpha is this. I used that a squared plus b squared is equal to 4r squared, and I didn't know what to do after that.
Okay, all right. I'll keep in. Just again, it seems that everyone had trouble with this problem, so I'm not very optimistic about how anyone got here much. So just now take this as an exercise for you, how you learned how to deal with that. Actually, in physics, inscribed angles, Thales theorem comes often quite handy. So you need to keep in mind Thales theorem is often in physics problems useful. Keep this in mind in future. And don't worry so much about the point. But let us finish
in mind.
Here. Let us finish this problem here. We still need to take the second derivative because we want acceleration as well. So now from here, we take second derivative of this expression. And then what happens? Now, I guess we need to make a break because we have now 4 minutes left until I told you that we have. I am using my non-pro account, which is 40 minutes time limits. I have still 4 minutes to go. I wonder if we can finish this within 4 minutes and then we can take next problem. Let us try. And so we have this expression here, and then we take now the second derivative. And then what happens is that here we need to take derivative of this, and we need to take the derivative of that, so derivative of a product. And so let me maybe switch to a different color. So we have now minus 2r, okay, sinus alpha, cosine alpha minus sinus alpha, cosine alpha minus sinus alpha, and now derivative of alpha, which gives us alpha double dot. I take this derivative of this expression, and I have one term which is alpha dot. I take derivative of this alpha dot, but I still need to take derivative of that thing here. So this goes now with plus, but cosine, derivative of cosine is minus sinus. So everything actually will be with minuses. So it will be minus 2r still, and then derivative of cosine is sinus, and derivative of sinus is cosine. So it is going to be now sinus alpha plus cosine alpha and alpha dot now, because I took derivative here. And all this equals to 0 because the v is constant. And so, so from here, I can express alpha double dot, which is the angular acceleration E epsilon, and this is going to be this divided by that. 2's cancels away, r's cancel away, and remains sinus alpha plus cosine alpha divided by cosine alpha minus sinus alpha, and multiplied by alpha dot. But for alpha dot, I have here expression. So this thing here next equals to sinus alpha. Okay, this in the denominator goes to square. So it becomes v over 2. Here I think I am missing some, but omega is alpha dot. Alpha dot, yeah, I missed here factor r, 2r, v divided by 2r. Okay, v divided by 2r divided by cosine alpha minus alpha here from here and from here. So all together squared, cosine alpha minus sinus alpha squared, and then multiplied by this factor here carries over sine alpha plus cosine alpha. Okay, and now this is epsilon, and now acceleration A equals angular acceleration multiplied by radius, and so this radius cancels away and remains now something V should go to square. Probably I have some omission here. Alpha is alpha dot, and alpha dot is here. V divided by 2. Okay, V 0.5 V 0.5 V, and sine alpha plus cosine alpha divided by cosine alpha minus sinus alpha squared.